Hello, this is Minhajul Abedin, and this is my presentation to the stakeholders for Coursera. Again, my name is Minhajul Abedin, and this is my presentation to the stakeholders for the Coursera capstone project. So basically, in my presentation, what I am going to do is I am going to analyze the sales of box office movies and see which movies perform well and which movies underperform based on many factors that play into role. So basically, these are my imports. So basically, you have your normal data science imports. You have NumPy, Panda, Matplotlib, and then other imports which I had to do research upon. So basically, what we're going to read it from the data set will be a GitHub CSV file. So I was able to find IMBD data from different movies, and basically the data was in a CSV comma separated file. So basically I used that. So first we have to take a look for the data I'm sorry. So basically if we take a look at the data that IMDb gave us on GitHub, this is basically what it is. So we basically can see that these are the top 5 values, the data.head. So basically, we could basically see after we import the data that if we use the data.head function, then we could see the first few columns of data. So basically, after data.head, we could see more quantitative data with data.shape and data.describe. So basically, with data.shape, we could basically see the rows and columns. And IMDb gave us a lot of rows and columns, 5,043 rows, I'm sorry, and 28 columns. So we're working with a large data set. I'm pretty sure that other companies like Google probably have millions of columns and rows of data set, but this is the data set that IMDb gave us, and basically we use the data.describe function to see what these rows are and what these columns are. So basically we're analyzing our data with all 3 of these functions. So then, to understand your data more, as I said, the data.head function shows data in the first 5 columns, the first 5 rows, and then data.describe returns general statistics about your data. And then when you do that, then the next step is you clean your data. To make a predictive model, you have to deal with the duplicates. So basically, we see that there are 241 duplicates in here. So basically, what I did, to deal with the duplicates, we basically have to have a function that would minimize it. So dealing with the duplicates, data is .null, .values, .any. So we use that to check if the data has any null values, because a lot of duplicates are null values. So we basically use that to see if there are any null or not available number of values, NaN values. So after that, we see that there are, so it comes up as true. So we make a function show missing data, and basically it shows the missing data from these 5 columns. And then we drop the data that's not available, and basically we just make the subset equal to gross. So once we do that, we can see a good understanding of what's not available, and then we drop that data. So then we fill out the missing budgets with the median budget for the year it was released. So going back to the slides, so this is the function we have. So basically we're going to clean the data with that function, and then you cleanse your data more and more, so dropping those values that are NA not available, and then we cleanse the data more. So we're going to delete the rows with title years of 0, and basically you would go another step in finalizing the data that you're going to clean. So after that, we look in the data points with the missing budgets, and then we fill those in with values that are estimated by median budgets per year, so it's a rough estimate. And then these were the steps that I showed you in the slide, 3 steps that were going to come up. So this is the steps that we would take in basically cleansing your data. So a lot of data science is basically cleaning up data, because if you want to make a predictive model, you want the model to be as accurate as possible, and basically you want the model to read the most value, the most possibly accurate quantitative values, because you're using these models to predict something, so you want the prediction to be accurate. So with the data sets, of course, like databases, a lot of the data, it's it's duplicated data, it's no data. I mean, that's normal in a database. So there's no other way that it can be cleaned other than using code to clean it. So that's what we're doing right there. And then we basically, the next methodology we're going to do is visualizing our data. So basically we're going to make a histogram at first. So basically with the histogram, we're going to see what a histogram would plot for the movies per year. So basically the titles and the movies, as we can see a trend that is not surprising based on the data set. 1920s, we didn't have a lot of movies, which are not surprising because at the time movies weren't that popular, and with World War II and other things happening in the world, it wouldn't be a surprise that movies were not huge of a thing. And then we see it steadily increasing as technology gets better and bigger. So 2020 is coming up, and with the year of movies that's happening currently, this is no surprise with the titles and then the revenue that each movie is gaining. So if we plot this as a histogram, then we see something like this, which is not a surprise. So then we take it a step further. Let me go back. So basically, we could basically do a scatter plot. So I'll show that later. But before the scatter plot, it's around here. Okay, before the scatter plot, basically we're going to plot the median gross of actors accordance to the films. So basically, which films do good based on the actors. So basically, these films gross in millions because these actors are in it. So that's one thing that was in the IMDb data set. So basically, how did we do that? So let me tell you how the way we did that. So median gross box office per actor. So basically, what I was trying to do is I was trying to group the data by the actor's name and the gross. So basically, you have the actor's name and the gross. So basically, what we're going to do is we're going to find the value that the movies have, the gross value, and see which actor makes the movie gross the most. So basically, we have a X and then Y label and then a title and then legend. So basically, what we're doing is we're trying to graph it out to the point to see with this function what movies were successful based on what actors were in it. So if we see Robert Pattinson was one of the more successful actors, and he had a lot of gross in the millions. So we could also see that Tom Cruise was not as successful as the other actors, and so basically we could see that actors that are more successful are actors that are in movies more often. Like Rob Pattinson was in Twilight movies, and Chris Hemsworth was in the Avengers movie. So basically, we can see that one thing that correlates with sales is basically that these actors are in recurring movie series. So as I was mentioning, after that we have a scatter plot, and it's not really hard to make a scatter plot. Basically, we're going to take the data and we're basically going to do a data.plot.scatter, and then x equals title year and y equals rows. We'll do the same thing for budget. Wait, I'm sorry. Let me describe these two scatter plots. So the first scatter plot was year versus gross, and then the second one was going to be budget versus gross. So basically, with this, what we're going to do is we're going to see the year and the gross per year. I mean, and if we see this, is not really surprising because, as I said, as and technology became more powerful, the gross increased. So that's really not something that is surprising. It's not really surprising. And then we see budget and then gross, and then we could see that if people spend more on budgets, it could correlate to more sales, where we see if they spend 2.5 million, 2.5 as a metric in the budget, then we could see that there's more gross. So that's something we could see in the scatter plot. And then basically with the data, basically we are trying to get the numerical data. So basically with that, we are having a function which which I believe I believe it calculates the aspect ratio and it provides us the useful info that we need. So basically this is our numerical data. So if we look at the data, we can see that these were the data that was provided by the IMDb database, and then we could see that the data is scattered across, and the number of critics per reviews and the durations and the actors likes on Facebook, and then the gross have some sort of correlation. So we can also see that as something that is possibly a correlation to movie sales. And so basically this is a process in data science where I would call it getting the quantitative data out of the data set. So that's what we're doing right now. And after we do that, we should do the next step, which is basically a training regime for the data. So we need to train our data and prepare the data to be tested in the data sets that we are given. So basically, what I'm trying to do is a linear regression, and a linear regression is one of the more it's one of the more valuable types of measurements in data science, and it's one of the most common types. So basically, what I'm trying to do after we train the data, as you can see, the data sets are right here, and we're printing out the data that is trained. So 80% to 20%, which makes a total of 100%. So basically, if we see it with the linear regression, we could see that we're putting the model as a linear regression model, and then we're trying to predict the model afterwards. So basically, we have to find the mean squared and the variance score, and then if we do that and then we make a scatter table, then we see the variance score is 50% and the mean squared error is 20. So basically, this is one of the steps that we use in the linear regression testing. So basically, that's what we're doing. We're testing our data, and that another thing that we have to do is get our error metrics. So we have to get the error metrics to see how much error that the data sets have, but that's something that I'll go on to later. So the next type of methodology that I was stressing about and the discussions were the random forest. So we're using a random forest regressor. So basically, to code it wasn't that hard, but the forest that we're using, it's called a random forest regressor. So we have the max depth and then the minimum samples and the estimated and the state. So basically, if we set the parameters on that and we set a forest, then is one of the things that the force gives us. So it gives us an array of real numbers. So getting back to the error metric, so this is basically our error metrics, and just basically the function that would probably understand the error metrics. So then we see the metrics and the visualization for the movies that are performing over and under. So basically with that, the numerical data that we have, this is the few functions that would help me in order to see the movies that are performing well and the movies that aren't. So let me go to my slide. So after there, so yeah, it's right here. So basically this is our prediction step. So basically the way we would predict this is basically we would go and make a plot, a bar graph, and a bar graph is one of the most beautiful ways of visualizing data in data science. It is one of the most cleanest ways, and it's one of the more efficient ways. As you saw, I use more of scatter plots and different kinds of plots and histograms for the past visualizations, but the final visualization, the prediction, should be in a bar graph. So basically this is what I'm doing. So basically I am setting the title to overperforming movies and then the Y label to this, and basically I am going to see the movies that are overperforming using my forest regressor function, and basically the final product should be this. So the overperforming movies, the gross is higher than the predicted gross. So basically if we see the movies, this does make a lot of sense. So E.T., it was a movie that had a lot of success in the, I believe, 90s or 80s, and it grossed higher than the prediction that it would gross. So that's on par. And then we see Avatar, which broke the box office records. So it grossed more than the prediction, which is something that I see, and that's something that's actually true. That's something that actually happened also. Jurassic World. I don't know a lot about Jurassic World, but I know that when it came out, a lot of people watched because they were nostalgic about the past Jurassic Park movies. So you could see that the gross is higher than the prediction, which is no surprise. And then we see Star Wars, a really nostalgic movie, which the gross is higher than the prediction. And then we see American Sniper, which is lower gross than all these other grosses, but it's a still higher than the prediction, which isn't really surprising because American Sniper doesn't have the amount of popularity as say Avatar would. And Avatar being the highest grossing isn't really a surprise because it was the movie. It was the movie that shattered box office records for the most sales, I believe, under Avengers Endgame. So we do the exact second function for overperforming movies. We did this for overperforming, and now we do it, and we're still on the overperforming movies, but in a way, this is basically the gross underperforming the prediction. So basically, this is the opposite of the other one, but it's still overperforming movies, but with the, again, gross underperforming the prediction. So Interstellar, as we can see, it was really hyped, and a lot of people were excited about it, but the gross didn't exceed the predictions. And we can see that Batman Begins, which I believe was the first one, did not exceed the predictions, which is no surprise because it's the first movie in the series. And then Prometheus, it basically did not hit the predictions. We could see that. And we could see Pacific Rim and Hugo not even close to the predictions. So those did not gross the predictions. So yeah, this is basically my data science capstone project. So basically, I've did a lot of methodologies that were taught, random forest trees, and then linear regression, scatter plots, cleaning up data, which was heavily emphasized, dropping null values, dropping values that have duplicates, uh, basically finding median values for values that are uh, erroneous. So basically, I implemented a lot of things that were taught towards the semester, and this model should work. And where I see this model in the future going is the movies that, since we're in the age where movies are really popular, I could see this model being used in the future movies industry, and especially with Marvel movies and the blockbusters that Disney are producing, we can make this model to predict the movies that many companies are producing, and we could see where they could go with the sales that they have. So this is something that could possibly be used in any industry, whether it be movies, music. I mean, you could use this for video games. So this model is really, it really took me a lot of time to think about it, and um, it's something that I'm really proud of. And yeah, so that's basically it from me. And hope you guys enjoyed, and hope the stakeholders enjoyed. And have a great day. Bye bye.